Okay, let's get started. So we're going to talk about pollution. Um, a lot of the stuff on water pollution was a little bit redundant, so we aren't going to touch too much on that. But we are going to talk about air pollution, municipal waste, which is pretty much land pollution, and then talk about hazardous chemicals. Okay, so we'll start with atmospheric pollution or air pollution. Um, there are a few different types. First is industrial smog, which really came to the scene with the Industrial Revolution. It's a combination of smoke and fog found where you have a concentration of manufacturing and industries, especially when you have coal being burnt or other um, similar kind of dirty fossil fuels, right? So that's industrial smog. You also have photochemical smog, and so this occurs when you have a lot of automobile traffic in an area. What happens is the sunlight reacts with the um, exhaust from the cars, and it goes through a reaction and then creates this with smog. Okay, so this is a particular concern in areas that are very dense, such as cities, surrounded in some sort of valley, which kind of traps all that smog into one area. These atmospheric pollution can be a primary pollutant, which is the direct product of combustion and evaporation. So industrial smog, most of that is direct primary pollutant. And then you also have secondary pollutants, which go through an additional reaction in the atmosphere, usually with sunlight or ozone, to produce a different substance, which then hangs out in the atmosphere. So photochemical smog is a secondary pollutant, and there are lots of pollutants from industrial smog, which also turn into secondary pollutants. What happens with acid rain or acid deposition or acid precipitation is when you have rain that is more acidic than usual due to these acids in the air, which then collect in the water and then during precipitation events start to acidify the land and waterways below it. Mostly caused by sulfuric acid and nitric acid. We'll talk more about this in a minute, though. Another thing that occurs sometimes to kind of trap atmospheric in an area is called an inversion layer. So this will happen in some areas where, you have kind of a valley which traps air. In normal weather patterns, you have warm air rising, and then it cools as it rises. So the coldest air is higher in the atmosphere, and then the warmest air is closer to the surface. A certain specific weather pattern can sometimes cause the warm air to be trapped above the cool air, which is what you see here. And this is called the inversion layer. The air is inverted, right? So the warm air is on top of the cold air. And what happens is you have all your pollutants still coming and emitting different things, and it gets trapped under this inversion layer. And the air doesn't mix and naturally float upward. So if this lasts for days and sometimes up to a week, then you can have a very thick concentration of polluted air, which can cause many health hazards. So some of the effects then, human health. We, of course, have to breathe the air, and everything we breathe goes into our lungs and can trigger certain reactions within our lungs. One of them may be asthma, which is the constriction of airways as a reaction, kind of an autoimmune reaction to a foreign substance. The things you are allergic to cause severe constriction as well, or can. Asthma is having those restricted airways and can be aggravated by and caused by pollutants in the air. Things can also in the air cause cancer, a COPD, chronic obstructive pulmonary disease. They also affect things in our environment. So they'll damage crops. You see an example of that here. They can damage the forest. They can even damage the building. So this is caused by acid rain. The acid is actually weathering away the stone sculptures and making them very disfigured. This acid also hurts things that are alive in the lakes and the streams. So before we had regulations, you could pollute whatever you want into the air. Well, eventually this became overwhelming and led to the Clean Air Act of 1970, used a command and control tactic to regulate and force pollutant concentrations. It had just been getting too bad. There were amendments in 1990 which added even stricter guidelines for enforcement after the ones were considered not conservative enough, and so they made them even more strict. This has been very successful in reducing concentrations in air pollutants. So sometimes a command and control strategy faces a lot of resistance. This is one that has a lot of public support. You don't want someone or some things or some businesses air pollutants going in and causing health problems to the public. So another area in the atmosphere which is prone to damage by pollutants is the ozone layer. And what ozone layer is three oxygens bound together in the stratosphere, and it acts as a barrier against ultraviolet rays from reaching the Earth's surface. And with the industrialization of a lot of products came the invention of aerosols, including one called, or a group called chlorofluorocarbons. And when these were emitted into the atmosphere, caused ozone to break down, and this caused a large hole over the Antarctic landmass, so over the southern pole. In 1987, the Montreal Protocol was passed. The U.S. and 194 countries agreed to reduce chlorofluorocarbons, and eventually they were phased out completely in 1996. This has led to a lot less of those ozone destructive materials into the atmosphere, and the ozone layer has started to recover because of it. So this is a great success story of actually environmental policy, environmental coalitions between countries actually having an effective outcome. Similarly, acid rain, with industrialization came a lot of acidic rain in Europe, US, Canada, and it caused the rainwater precipitation to be at a pH of 4 or less, and normal precipitation is at 5.5. So 7 is neutral. Anything below 7 means it's acidic. So normally rain is a little bit acidic, but not that acidic. And what it caused was a lot of damage in vegetation, damage to minerals, which normally were in streams and waterways, which allowed the growing of animals and plants. Those minerals got caught up and started reacting with the acid, and so were unavailable to plants and animals. It also caused damage to forests and roots and lots of other things. So kind of widespread damage, which led to the regulation of emissions which caused this, sulfuric and nitric oxide, and has since caused a major reduction in acid rain as well. So this is from 1994, very acidic, especially the east side. But since then, 2012, we've had a lot lower acid, and anything really below 4 is very, very, very rare. So another kind of success story. Still, there's some work to be done there, though. All right, now we're moving on to municipal solid waste. So this is kind of a hard subject to talk about because we all produce a lot of garbage and we just throw it away and then you think nothing is done with it. Well, municipal solid waste then is that garbage, the total of all the materials thrown away from homes and other smaller commercial establishments and collected by the government. Well, what do they do with it? Well, generally they just throw it in a landfill. They dig holes, dump it in there, and then cover it with earth, right? Well, what happens to that trash over time? Unfortunately, some of it creates toxic environments, which leaches into waterways, contaminate waterways. Creates you do have a very slow breakdown of products under the dirt, so it sometimes will produce methane, and eventually landfills become too full. So you have to find another way to, or another place to kind of chop down some trees and dig a big hole and put more trash in there. Unfortunately, also a lot of this trash, incidentally so accidentally and on purpose sometimes, is just dumped into waterways, and that eventually then gets into the ocean. So much of our trash actually has made these large garbage patches in the ocean, where this currents just kind of swirls the garbage around in circles. This can damage wildlife. Things like plastics don't break down in the environment. They do get smaller and smaller and smaller, and then eventually become to sizes where other animals will ingest them, confusing them for food, or incidentally just as they take in food with other stuff. And this is bad for organisms. A lot of this has settled on the ocean floor, and it's going to just be there forever. We can't go and vacuum out the ocean. The ocean floor, we barely even can get to them. So the damage involved in this, a lot of it, we don't know what's going to happen, but it's there, and it's out there, and it's continually growing. Probably needs some efforts to clean up the oceans. So some solutions to this: well, we can improve landfills, make them better able to hold materials and not leak toxic things into our waterways. We can burn it. We can burn trash, and and we can even use that burning. We can use it as fuel to create energy. We should reduce the amount of things we throw away. One of the ways we can do that is through composting. Excuse me. Which is taking biodegradable waste, putting them outside, exposing to the sun essentially, and allowing them to decompose, and then you can use that as fertilizer. Recycling is huge. So taking our garbage and using it again to make products. Saves energy and resources, decreases pollution. However, it does cost money, and oftentimes costs more money than just making new products. Integrated waste management involves using lots of different things in order to try and get at all the problems associated with municipal waste. So this is kind of one idea of how you might be able to do things kind of all at once, is creating, rather than just burying things, is to filter it out, recycle the metals, maybe even take out the plastics, everything else, shred it up, and burn it. And you can have different ways in which you can save some of the things, or like have a recovery system for the metals, try and reduce emissions, and then create electricity and put it into the power grid. We have shown some progress in these areas, especially recycling. We're starting to recycle a lot more, especially since the 80s. Still, we're only at about 34, 35, so about a third of our garbage is recycled. 2/3 of it is still going to create a big problem as to what to do with it. All right, so that's municipal waste. Now we're talking about hazardous chemicals. All right, these are abbreviated hazmat. Any chemical that represents a hazard or a risk. The things that make it hazardous or a risk include how ignitable it is. Will it catch on fire? Will it corrode things such as metal storage tanks or plastic or equipment? Is it reactive? So if you mix it around other things, it's going to cause a chemical explosion or toxic fumes. And is it toxic? Are they going to injure the health of people when they are ingested or breathed? The source of many of our hazardous chemicals are part of the processes of making our products. And so one thing to consider is the total product life cycle of whatever product you have. So if you think about your cell phone, all the different metals that had to be mined, the plastics which had to be made, I don't know what else goes in there, but electrical components. All of these had to be put together, and some process went into doing it. And a lot of chemicals were made and used, and there's byproducts of each. And so there's a lot that goes into each of them. And they only last for a year or two, then you throw it away, and you have all these even hazardous chemicals within them. So a lot of things have specific instructions for how you're supposed to dispose of them, especially electronics. But when you think about this, it's a little bit disconcerting about, well, how can we do this better? Well, and a big question is, have we been doing better with the toxic things that we release into the environment? And I think since the 50s and 60s and 70s, we have done a lot better. But we haven't shown too much improvement in the last 10, 15 years or so. And this graphic kind of shows that. We do at least keep track, though. So industries have to release information on what they have been emitting, how they've been controlling for it, whether things were recycled or combusted for energy. And but there's still a lot of work that needs to be done here. Some of the solutions of disposal include deep well injection. So if you can dig a hole far enough, you can actually dig things down into areas which aren't going to affect drinking water or anything. And so that deep well injection is one solution for these hazardous chemicals. Surface impoundments are also used, where they have a pond, a large area where wastes are drained and held. What we do with that area makes it quite unusable for anything in the future. And of course, we have landfills where we will treat chemicals before they can be put into landfills. Now, a lot of damage has been done for toxic spills, whether by accident or by purpose, and creating these areas that need a lot of help. So some of the things we do that are called groundwater remediation, where you pump out contaminated water and treat it at the surface to try and create a uncontaminated water source again. The Environmental Protection Agency has and continues to identify areas which need a lot of work. And they provide a lot of money into restoring, reclaiming, improving these areas, because these generally have a large area, lots of people in which that they can affect, and the improving or the benefits for improving the area are widespread as well. I think the Chesapeake Bay is one of these sites which has been polluted for many years, and a lot of money is going into making the Chesapeake Bay a more pristine environment for organisms. Another thing you can do is use bioremediation. So even bacteria have been used to help clean up oil spills, or maybe help break down other toxic chemicals. Remediation is also using plants to soak up contaminants as they grow, and then treating the plant material as hazardous waste. So there's a lot of different creative ways in which you can deal with these, take them out of the environment and dispose of them properly. Other solutions we just talked about, but they can be broken down into these four major categories. So you can prevent pollution, changing the production process so there's less emissions, less toxic waste, the materials are more environmentally friendly, and so forth. You can recycle solvents and lubricants and use them over again. Treat them, so by breaking them down and converting them into harmless products, or just finding a way to dispose of them safely. Maybe even incinerating them, right? Some of the policies which have been kept to help the public and especially people that work are the RCA, Emergency Planning and Community Right to Know Act, informs the public of storage and release of toxic substances, which is great. So you can't just dump something and not tell anyone like you used to be able to do. The Clean Air Act limits what people can put into the air as far as hazardous pollutants. And you also have a regulatory organization which helps the risks involved with work. So OSHA, the Occupational Safety Health Act, protects workers from going and having to do risky jobs, dirty jobs, if you will. So a person, an employee, if they're going to take a certain risk, the boss or person in charge has to notify them of the risks, properly train them for the risks. There are certain things employers do not have to do no matter what, and can't have any reciprocation from that as well. So this is just kind of a full, figure showing everything that we have to help us with our hazardous waste. The EPCRA, Clean Air Act. There's also a Resource Conservation Recovery Act. The Department of Transportation allows for the safe handling of hazardous materials. Superfunds provides cleanup. Safe Drinking Water Act keeps these things out of our water, as does the Clean Water Act. And then we have the TSCA, the Toxic Substance Control Act. It requires chemicals to be labeled properly, and that label is also a representation of the law and how they should be handled. Okay, that's it for pollution.